So welcome everyone to the Simio Solution Series, July 14th. Today's session is going to be on optimizing a manufacturing cell. My name is Dan Vasilini. I'm the VP of Global Sales here at Simio. Doing most of the presenting today is going to be Chiara Bondi. She's one of our solution engineers here at Simio. So before we get started with Chiara's presentation, a few housekeeping items. So today's session is being recorded for replay purposes. If you'd like to rewatch the session today or suggest it to a friend or a colleague in the future, we will be posting this to our webpage shortly. Now, normally, I'll put the caveat out there, normally we do have this thing posted within about 12 to 24 hours of recording it. We do have some website construction slash work going on in the background, so this session may not be posted until early to mid next week. So perhaps around the 18th, 19th, 20th is when this one will probably be posted, but just keep checking and it will be out there as soon as we can get it up. Also, and every participant entering today will be coming in on mute. If you do have any questions during today's presentation, you should see a GoToWebinar chat box or a bar somewhere on your screen. On my side of the screen, it's on the right side. In that box, there is a question and or a chat drop down. If you have a question during today's session, please simply type it into the question area and we will get to questions. If the question is specifically relevant to something we're talking about at the time, I do try to interrupt and ask the question before we move on to something else. If the question is more generic in nature or something that can be addressed at the end, I do try to hold questions like that until the end so that we can get them all answered at the same time and I don't interrupt the presentation. Lastly, today's session is scheduled to last about 60 minutes. I think with Chiara, she will probably be presenting for about 40 to 45 minutes. So we should / will have time at the end for questions. So I would expect to have 5 to 10 minutes at the end for questions. So once again, please feel free to type those questions in as we're going and at the end as well. All right, so when last we met, we did not have our next scheduled sessions ready yet for topics, but we do have them now. So first and foremost, I want everyone to draw attention to, or I want to draw everyone's attention to the future. We are going to switch our solution series over to Friday. So it'll be Fridays going forward. It'll be at the same time, 11 a.m. Eastern Standard Time, or depending on where you're at around the globe, it'll be at that time for you. So same time, but we are going to switch over to Fridays. We just from a very high level perspective, the Fridays and Thursdays we seem to be getting around the same type of traffic, and it seemed like Fridays were a little more requested here recently to get them back on the calendar. And with the end of summer coming in certain places here, especially in the US, it seems like more people are interested in doing these sessions on Fridays. So we have 2 sessions right now on the calendar. Normally we do these things bi-monthly. We are going to do 2 sessions for August and September, or 1 in August and 1 in September. You can see we're doing Unlock Your Models with Process Logic on Friday, August 19th, and then we're going to dig into material handling on Friday, September 16th. These are not on the Simio webpage yet, as I mentioned earlier. They will be going up soon as we get finished with our website stuff that's going on behind the scenes. But at least for your calendars, or if you're watching this session on recording, more than likely these sessions will be live that you can actually go ahead and register for them now. So those are the next 2 sessions on the calendar. Any future suggestions that you might have, we are always willing to and listen to any suggestions coming in from the base. So if there is anyone out there that has any suggestions on what you'd like to see in the future, please let us know. You can email directly to me at dvasilini@simio.com. I'll leave that up here for a second for you to write it down. But any type of suggestions you have, like I said, feel free to reach out and let us know. Lastly, before we jump into Chiara, so Simio Sync 2022, our biannual Simio conference. Once again, it is going to be done remotely. It's going to be a 1-day conference. It's going to be virtual on October the 25th, Tuesday, October the 25th. We already have some keynotes. We already have some speakers identified. You can go to simiosync.com to start registering. Right now, as far as an overall overarching theme is concerned, we're finalizing that theme as we speak, but we're about, a little over 2 months away from it. Well, actually, a little over 3 months away from it. So as of right now, we're just looking to get registration set up and get people in the queue If anyone does want to, throw their hand up in the air for being a speaker or anything, feel free to reach out to your account manager, reach out to me, reach out to one of our tech folks, and let us know. With that said, I will go ahead and stop sharing. Kiara, I will turn the presentation over to you.
Awesome, thank you. Well, hi everyone, I'm Kiara. I'm a solutions engineer here. Thank you for that introduction, Dan. And today I will be presenting, talking about how to optimize a manufacturing line. So I will turn off my webcam now and share my screen so that there's no issues with presenting the model or anything like that. So here we go. And now we're going to, so now we present. Here we go. So amazing. So just to confirm, can everyone see my screen?
Yep.
Amazing. Awesome. So as I said, we're going to talk about how to optimize a manufacturing cell. And we're going to be looking at how to do this through creating custom objects and how to set up experiments so you can look at different scenarios, different setups, different properties, and see how that changes any key indicators. So to set the stage, we're going to be looking at a very simple, manufacturing plant with a few different cells where there's going to be workers and different stations. They're going to be taking in orders and then using material to produce a certain product. And what we're going to be looking at is how to create these cells and then how to create different experiments and how to set it up so that you can maximize your throughput and minimize total overall costs within a budget. So we're going to have some sort of restrictions on how much you can spend, and we're going to be looking at how to implement those. And so to do that, we first need to understand what a custom object is and how to create it. So we're going to briefly introduce that, and then we're going to look at in the Simio software how you can create different scenarios and easily change them in your model so you can look at how your run changes by implementing those modifications. And then lastly, we'll be looking at how to set up experiments and specifically how to use the OptQuest add-in to generate all of your or multiple different scenarios to optimize a given objective. So firstly, what is a custom object? So a custom object is a modeling construct within Simio with user-defined logic. So it would be your standard object that appears from a library, such as a server, a worker, a sink, but the user has implemented or modified some of its characteristics, data, or logic, and really changed its behavior or appearance. And there's many ways or multiple ways that you can do this, but we're going to be focusing on two main procedures, basically. Subclassing an object from your library and creating a new object from what's given, and then creating a model hierarchy. So we're going to be looking at how to create submodels within a larger model. What's really useful about custom objects is you can, override processes, add state variables, and change the external view of it so that you can really add as much logic to it as necessary and really represent a real or accurate representation of a station or a worker. And these are specific to your organization. So these can really be as specific as you need for your model. And once you have these custom objects, you can share them within your company and you can actually share them with other people so that they can then implement them into their models as well. So now that we have a little bit of this introduction, let's go ahead and jump into the actual software itself. So here we go. Here we go. So can everyone see my Simio window? I'm going to.
Yep, you look good.
Excellent. So as we see here, we have our standard empty facility with our objects here in the library. Now, suppose you're trying to model a working station that you want to use a server for. So you can drag a standard object here and you'll have a server with all of its default properties. But say, you know that the runtime is not random. It's a specific runtime of, let's say, it's going to be 5 minutes. So I'm going to modify this to be of 5 minutes. So now I've modified one of its properties, which as you can see appears bolded. Now, if we wanted to create, say, 6 different servers with the same runtime and the same modified property, we can easily, drag and drop or create 5 servers and then in each individual one change the processing time. Or we can create a custom object where this modification or this new processing time, for example, is its default value. So if we right-click on our server, we can see there's a bunch of different options. You can rename it, you can, set a breakpoint, or there's this, which is create object from this. And what this does is it'll subclass the server. So it'll copy all of its process logic that's currently, you implemented in the basic server. But by creating a new object, it'll save any modifications that I've made to its process logic or any other property, setting it as a default. So I'm going to create an object and I'm going to call it, my custom server. And as we can see now, it's changed its name. And if we actually click on it, it's now a my custom server object. And it has a processing time of 5. And it's no longer bolded because it is now its default value. And if we look here at our project library, it has appeared right here as my custom server. So if I drag a standard server out, we can see it's named server 1 and a processing time is what its original default value was. But if I now drag a my custom server, its processing time is 5. Now, another feature that's very useful is if you want to make any change to all of your custom servers, instead of, clicking into each individual instance or then creating a third object, you can make that change. So say I want now all of my custom servers to have a capacity of 3, so they can process 3 entities at a time. We can see now that right below the create object from this, we have a new option, which is to update the property default values from this. So doing so, as you see now, my initial capacity is no longer bolded. And if I go into my first custom server, that change has been modified. And we can see now that its default capacity is 3. And again, if I click into standard server, that has not happened. That's original, its default properties are exactly the same. So now that we have the basics of how to create a custom object, I'm going to jump into a model. So this represents a single individual manufacturing cell. And as we see here, I have these servers named as my servers because I created, prior to this, a custom server object. And as we can see, all of these, nothing here is bolded because I have set it up so that everything that's currently here in my server is its default properties. And the main change, modification that I made from the original standard server to this object is, as you can see here, there's a little green arrow because I have set up a reference to a table with task information. So if I go just very quickly into my data, there's a table here that specifies all the different tasks that I want my servers to do with its processing time, material requirements, worker requirements, etc. And so when I set up my custom object, I set it up in such a way so that it has that reference, as you see all the green arrows, automatically set up so that it has the task name, the condition of processing, processing time, worker requirement, material consumption, etc. So I'm going to have this run just very quickly to show then how this is going to work. And to set up here is I have 3 workers. I have a product worker, an examiner, and a storage worker. And what's going to happen is we're going to have entities arriving to the servers where an examiner is going to check what the order is. It's going to then transfer into the work or the working producing stations where the product worker is going to go consume some material. And then once that's done, it'll be sent to these quality control stations where again, an examiner is going to be needed. And once that's complete, they'll be sent out of the cell. And all of the different material units are going to be stored in this rack. So once we reach a certain threshold of material, in stock of quantity in stock of our material, we're going to have a storage worker take one unit from the rack over to this server to be unboxed, and then from there over to the working stations. So I'm just going to very briefly run that. And as we can see, we have this working. Now, what's really useful about custom objects is we think of objects as just what appears into our library. So a source, a sink, if we go into the flow or extras library, we'll have everything here. But a model itself is an object. A model that you create is in and of itself a custom object. And that is where the creating model hierarchy comes into play when creating new objects. Because what we can do is we can build a model such as this one and use it as a submodel for future larger facilities that want to, for example, expand a larger plant or manufacturing line. So here, for example, I have just a standalone cell with the same logic and the serve and all of the workers and everything. And here I have a larger model where we can see the same layout with the servers and the workers. But these are not just servers themselves. This is an object. This is the cell that we looked at before, which is now a custom object. And in fact, as you can see here, it appears under my project library, and I can drag and drop it into the model just like any other object, just like any other server, worker, vehicle, etc. So I'm going to delete this instance. But here now, thanks to Simio's custom objects, I have created a model hierarchy where we have this custom object, aka my individual cell, as a submodel within a larger facility. So here we have this manufacturing plant with 3 different cells, and here are going to be my storing, the storing of all my material units. This is where they're going to be unwrapped and unpacked and processed before being brought back for replenishment into my individual cell. Now, before I continue on with this, I'm going to go back into the smaller version of this model and run this for a little bit to show you that with the current setup I have, we're going to see some buildup of entities at the different servers. We can see that there's entities kind of just waiting here. There's, a lot of utilization, a very high utilization of my 2 workers that are going to and from these servers. And this is probably not ideal. So we would want to see what happens if we change, for example, the number of product workers or examiners. Now we can easily go in here and, change, for example, the population. Let me reset this for a second and change, for example, the number and system from 1 to what happens if I have 2 product workers, which now is bolded. But to make this a much easier process, what we can do is create what we would call, or what Simio calls, properties. So these properties, as you can see, I have a few already created, are different, if, for example, here they're expression properties or integer properties. And what these allow us to do is create references to them so that then we can use them as controls here on the right-hand side of our model. So as you can see, I have a few different controls, specifically regarding the material reordering points, as well as the population of my product and examiner workers. So I'm going to here set a reference as you see, set reference, and it's going to give me two options, either examiner or producer, and that is because these are the only two properties that are integer properties. We can't have a fraction of a worker in our cell, so we want integer properties, and so I can set this reference to my producer, and now I can go into my controls and just change this value here from 1 to 2, and maybe I want to look at what happens if I have 4 examiners. And now we can see that thanks to those references, we have more workers, and we can see that there's much better flow of material through our cell. So this is how we can create, different scenarios and kind of visualize them quickly. But what if we have many different scenarios and many different options, such as 3 workers, 2 examiners, maybe 4 product workers? It'd be quite time consuming to just manually change them one at a time and look at the different outputs, maybe stored into your results table or maybe in an output table. So that is where our experiments are going to come into play. So here, as we see, I have many different controls. We're going to have the number of examiners in each individual cell, the production capacity for our production servers, and then the number of product workers in each cell. And for the sake of simplicity, we're going to assume that each individual cell will have the same number of product workers. Now for the material reordering, which we will look at lastly, as you see, there's 3 reordering points. There's reorder material, reorder point, and reorder quantity. So the reorder material point refers to how many units are left in the cells in the racks themselves. So once we reach, currently all these racks are only storing 12 units of material. So we're going to look at, and obviously if we reach 0 units of material, we cannot replenish anything in the cells. So we want to figure out, when do we restock our racks with new units of material? And also we're going to want to look at, when do we bring material over to each individual cell and how much? So that's the reorder point and reorder quantity. And lastly, before we jump into the experiments, as I mentioned before, we want to maximize throughput but minimize costs. So throughout the model, I had implemented different costs. So if we go into the individual cell, we see that there's some usage costs associated with the product worker, with the examiner, as well as holding costs for the different servers. So that would mean if there's a lot of entities waiting in the input buffer, that's going to cost a lot to the manufacturing plant. And in the main cell, there's also going to be some costs associated down here for the actual unpacking of our new material units. So I want to run this really quickly to fast forward and show, as we can see, suppose we have a $10,000 budget. We can see that the current setup, we're not really producing that great values, or we are producing a good amount of output, but there's a lot of buildup occurring and it's above our budget. So we want to figure out how to modify all of our different controls so that we can bring this cost down but still maximize our throughput. So here is where we start looking at our experiments. So I have set up 2 experiments. Sorry, let me just reset this. So I have set up 2 experiments. I've set up one where we're going to look at only the workers themselves. So as you see, here are all of my controls, and I have specified here that my material controls are not going to be used in the optimization, and my workers and anything that involves production will be. And all of this is done thanks to the OptQuest add-in. So what this allows us to do is it allows us to automatically create multiple scenarios. So in an experiment, you can easily just create all different scenarios and manually specify your controls. But what the OptQuest add-in allows you to do is to define a very specific objective of value or function that you want to optimize in some way. So if we look at our experiment, we can see here I've already added the OptQuest add-in, and it has all of these different parameters. And what's key is the objective type. So here I have a multi-objective weighted goal, basically, where what I want looking at is I'm going to be looking at 2 responses instead of 1, my throughput, which I want to maximize, and my cost, which I want to minimize, and I, as you see, set an upper bound of $10,000. So because of this specific goal, what OptQuest will do is it'll automatically create scenarios to optimize our objectives. So maximize as much as possible the throughput and minimize as much as possible our cost. And what's really unique about a multi-objective goal is you can weigh them differently. So if, say, throughput is more important than costs, as I have here, I have 80% of the importance, throughput is 0.8%, takes 8.8% of the weight, and cost only 0.2, meaning we're going to primarily focus on throughput with cost also as having some relevance. So if I run this, and we're going to just let this go, we can see that now we're going to be creating slowly many different scenarios. So here, for example, I'll have the production capacity ranging between 1 and 3 entities incrementing by 1. My examiners are going to be between 1 and 4 incrementing by 1, and so on. So if we keep this running, we will slowly start to see the different scenarios actually pop up right here. And you can see here that we have some red appearing in our cost. And that is because what this is showing us is unfeasible solutions. So this is telling us, hey, you set an upper limit on cost, and clearly this scenario is going above that limit. So here, for example, this would be an optimal solution because it's maximizing throughput, but it's not feasible because we are above our upper bound for cost. So I have already had this run all the way through. So I'm going to cancel this. This will just keep on going and show us all of our different scenarios. And if I have actually already run all of them, and as you can see, all of these appear with many different values and combinations of examiners, product workers, production capacity, etc. And we can see here, for example, that the optimal feasible solution is the second option, where we have capacity of 3 in our production servers, 4 examiners in each station, in each cell, and then 2 product workers. So if we want to look at see what this looks like, we can just right-click on this scenario and copy the control values to the model. So now, if I go back into the manufacturing line, we can see that these values are bolded and they're the ones that we took from our experiment. And because they're not the default values that we started with, they are now set in bold. So now if we run the model, we have our 4 workers, a capacity of 3 in the cells, etc. And this will run exactly the same, just with these new values. So I'm going to fast forward here and show that, okay, look at that. We have now gone below our budget and we have, still pretty good output. But what if we change now material reordering points and our replenishment policies? Could that help us maybe reduce more costs? Because maybe we have even less entities waiting. As you can see, there's still some entities waiting here. Maybe it'll help, balance out the cells so that we have also more output from cell 1 and cell 2 and maybe a little bit less in cell 3, so it's more balanced. We can set up an experiment that will only focus on the material reordering controls and set our production capacity and workers as constants. So as we can see here in all of these different scenarios now that OptQuest automatically generated for us, the workers don't change, but what does change is the different values for when to restock our racks with material units, At what point do we want to bring material into the cell? And when we do, how many units we want to bring back. So again, we can run this. And again, this is set up as a multi-objective weighted optimization problem where this is going to just automatically generate different scenarios to optimize our goal, which is the same as minimizing costs with the same exact budget and maximizing throughput. So we can see here all of the different values going through and everything changing up. So again, for the sake of time, I have actually already run this in a different model or in the different open Simio window. So I'm going to just go ahead and cancel that and just go straight here where I have already generated all of the different scenarios. So what's interesting is we can see here that these numbers might seem a little bit random, like, oh, I'm going to just reorder when there's 4 units left on the racks. I'm going to reorder for each cell when there's 9 units left in the cell, and the material that I'm going to be bringing is 26. And we can see, for example, here, all the different averaged throughout the 10 different replications done, the average costs and the average throughput. So you might see, for example, that the difference between, this scenario and this scenario, there may be not that big of a difference in throughput, but there might be a significant difference in cost. And this is where you start to examine, where do I want, what kind of values do I want to now implement into our model? But I'm just going to copy over the optimal feasible solution, which in this case we're lucky and happens to be the absolute optimal value. So again, I will copy these into the model. And as we can see, these have been become bold so that now these are going to be the new reordering points. And if I fast forward, we have increased our material output slightly, and we have actually decreased our total costs. There's less entities or there's less material units, excuse me, or orders just waiting here because we're constantly replenishing at the right times. There's just an overall less waiting at each buffer, and that is going to be reducing our main costs. And so now, for example, we can see how much we've improved from our initial setup where we're, producing, just over 2,600 entities with a cost above our budget of 10,000 to producing 200 more entities and reduced our costs significantly. And now our cells also seem to be a lot more balanced in output. So this is my presentation. These are this is going to be how you set up your experiments, and this is where then you can actually see through some charts or tables, as I have set up here, what the output is from the results in your experiments. So thank you very much for listening, and if there's any questions, I am more than happy to go ahead and answer them or dive into anything else that anyone is interested in.
No, perfect, Kiara. Thank you. And we've got a slew of questions, so sit back and be prepared.
Perfect.
All right, I'll try to go in the order they came in. Now, some of these might refer back a little bit early in the presentation, but let's get through them. So, does update in parentheses custom object property defaults from this work for all the objects properties, including tasks inside of a sequence?
Yeah. So let's go back here. So to understand the question, if we changed something within this task, so processing tasks, for example, if we added a new column to the table, right? And maybe it specifies different destination nodes. So what you can do is create a new reference here. So set reference to, a new destination where you might have that location specified from each server, or from each server to there. And once you do that, so for example, I'm going to just, for the sake of simplicity, change here from no request move. So we don't need the worker itself to actually go to the server. So I made that change, and we can see that that doesn't appear yet in all the other servers. But if I update it, and now I go into a different server, I'm just going to take this one for fun of it. We can see that the request move has now changed. It is no longer to a specific node, but there's no request move. So does that answer the question?
Yep. Perfect.
Excellent.
Perfect. All right. And like I said, I've got about 7 or 8 more questions here. If anyone does have questions that's on the line, feel free to type them in. We will try to get to as many as we can. Next question, Kiara. For inventory purposes, what are the benefits of using a rack object versus a server?
So okay. So a rack object in of itself doesn't do any sort of processing tasks, and all it does, it just stores your entities. So from a visual perspective, for example, or even a functioning perspective, the rack's purpose, let's say, is to actually just store entities in them, whereas to store them into a server and just have them waiting there, you will have to modify a lot more of its processing logic to allow it to maybe keep a lot of entities in the processing station. And then if you want to take them out, has more logic to it so that you can just release, for example, one entity over to the output node and then go and pick it up. It can be done. It's been done, where you can set up a server as a storage location. I know I've done it in other times to simulate free space storage of like storing something just on the floor and not in a structured location such as a rack. But that would be one of the main differences, right? Is a rack is purely just to store it, and you can have different also selection rules and use it, specify with racks, for example, if you want to store something and simulate pickup time. For example, if you want to simulate the time that it takes for here a lift truck to pick up an object that maybe lifts at a much slower rate to pick up something from the top shelf, and time is something that's very important to you, you can really simulate that really well using the rack object, where it might be a little bit trickier to do so with a server.
Okay. All right, and anyone that's asking questions out there, obviously, if we don't answer your question fully, or if you have follow-up to it, I'll flash Kiara and my email address one more time before we end so you can reach out directly to us. All right, next question. Can you elaborate on how you included financials into this model? What activities have costs associated with them?
Absolutely. So here, for example, some of the activities that have cost just in the general, then I'll jump into the individual cell to like look at them. But for example, some of the costs that I have associated are here. Let me stop this so we can see this better. Is the cost per use, say, of the server. So how much it costs to unpack one unit of material every time you have to bring it over to the cell. So if you're constantly replenishing your cells and more units are going into servers, it's going to cost you a lot more because each time you're going to get charged, for example, $30. As well as here, I have a storage worker where every time it has to deliver units from the rack to the server and then from the server to the cell, it's going to cost, some sort of financial value, such as, $15 an hour. Within the cell itself, so I'm going to go into the model. I have costs associated to the workers. So for example, I have my product worker, a use cost per use that's slightly higher than the storage worker, because it's going to have also more maybe how do you say expertise in terms of actually maybe producing something. And then on top of maybe worker costs, if you have entities to simulate, for example, and really understand where certain bottlenecks are, you can add holding costs in your buffers. So here, for example, in my servers, I have various holding costs where the more entities are waiting in the buffer to be processed, the more it's going to cost the facility itself. Because suppose you are producing some fresh goods, right? They can't be waiting forever. And so the more that they're going to be waiting and the more that they're just going to be stalled in say the buffer that has to process them, the more it's going to cost you because maybe they're going to expire or go bad or something like that. So these are where the financials kind of are added. These are just some values that I've used, but obviously if you have very specific or know specifically how much the cost rate of employees or stations, or for example here, buffer holding costs are, you can totally add these into your model right here in the financials property and see how these change over time by changing different properties or values.
Okay. All right, great. Thank you. And now several OptQuest questions here in a row. Can you control how long OptQuest runs for, or does it know when to stop creating scenarios?
Yes, so I'm going to go right here, and in our OptQuest parameters, you can specify the minimum number of replications and the maximum number of replications and the maximum number of scenarios that you want to look at. So for each scenario, if you're doing anything that involves randomness, right? So random waiting times, random arrivals, anything like that, you're going to want to create as many replications of that same scenario as possible so you can get a really good idea of how these this different scenario through different random values basically can really change and get a better sense of your response values. So you can say, for example, instead of 6, you want at least 50 replications done, right? To get a really, really accurate idea of the results of that specific scenario. And because OptQuest is going to automatically create scenarios for your specific objective, you might want to say, okay, I don't really need that many different scenarios. I don't need OptQuest to run infinitely. I just want to look at maybe the 10 best scenarios or only 15 scenarios. You can specify that right here so that, as we can see, it limits the number of scenarios that OptQuest should produce. So you can automatically set these limits yourself so that you can run this for as many or as few scenarios and replications as needed.
Perfect. Great. All right, next OptQuest. How do you tell OptQuest to fix certain controls, like the values that were fixed in the optimized materials experiment?
Yep. So how you would fix them, there's really 2 steps. So the first step would be to make sure that the values that actually you're going to use are the object's default values. So for example, I didn't really illustrate this or didn't really put that much emphasis on it, but as we can see here, the values for all my examiners are not bolded because in order to have them fixed in my model or in my experiment, excuse me, I needed them to be the default values. So once I copied them over from from the experiment's results into here, for example, I will show this here. So once I had copied them over into my model itself, so right here, as we can see, they're all bolded. What I did is you can just right click on your controls and then save all current values as default. So what that will do is it'll set those values, as you see, they're no longer bold, as the defaults. Once you've done that, you can go into your new, what's it called? Your new experiment. And here, because you don't want these, for example, to change, you don't want to change your production capacity or anything like that. Oh, I just realized. You're going to want to specify to OptQuest, hey, I don't want this included in my optimization. Do not do any changes to this. I want these to stay as the default values. I don't need you to do anything with them. I don't need you to care about them. Don't look at them. So we are not going to include them in the optimization. Whereas all the other values that you are interested in, we're going to tell OptQuest, please optimize these. Change these up in my min-max value ranges with whatever increment I've specified and use these in my optimization. So I will just show that now. Because my values of 3, 4, and 2 for my workers and capacity are set as defaults, and I've specified to OptQuest that I don't want these included in the optimization itself, these are going to remain constant. And these are going to not change and stay exactly the same for all of my different scenarios. But what is going to change is what I've specified to OptQuest to focus on. So right here, for example, in my material reordering, to include in the optimization itself.
All right. Let's try to stay on the OptQuest questions right now. We could just a couple more. Is there more information or documentation about the algorithm that OptQuest uses to create scenarios?
Absolutely. So you can actually go into support and go into help and search OptQuest there. And there is a lot of documentation and information specifying how OptQuest runs, how it actually calculates the optimal values themselves, and any other sort of information that you might be interested about.
Perfect. All right, and just as I'm saying that we're running out of questions, more questions are popping in, so let's try to get to them. Can the software incorporate random processing time with an input of a distribution model?
So for a server, for example, a random processing type, absolutely. You can, for processing type, you can have, here I have it as a task sequence, for example, set up, but you can totally change this processing type to it says specific time, but as you see here, this is a random distribution. And so you can change this into whatever you really want. So what's nice about Simio is it has a lot of different distributions. So discrete, exponential, a gamma distribution, normal, Poisson, anything else that you might need to, or that you know your processing time is, and implement that. And in fact, I'm going to exit out of here and kind of go back. In my task table, my processing times are in fact random. And they do have, I just set them up as triangular and uniform distributions, but you can have them set up in whatever you know your servers are working with.
All right. All right, let's just do one more question, then we'll end up here because we've been going for questions about 20 minutes here. All right, last one. What if I want to limit the total number of workers across different worker types? For example, I want to experiment with a different number of examiners, but ensure there are still only 8 overall.
Yes, so what you can do within your experiments, optimize, so if we look here, for example, you can add, add a constraint to your experiment. So what you can see here is you can add an expression in your constraint that specifies, for example, the sum, I want the sum of my workers, so examiner 1 plus examiner 2 plus examiner 3, to be less than 8. So that way, what this will do is this, so that you can basically set up this constraint in such a way so that OptQuest will only look at values that satisfy these constraints. So for example, it wouldn't even look at this first scenario, 3, 6, and 9, because maybe you set up a constraint such that examiner 1 plus 2 plus 3 is less than 8. So you can add in these constraints and specify anything else, any sort of constraints or limitations to the different scenarios that you want to look at. And this is also explained a little bit in more detail in the help window for the OptQuest add-in.
Perfect. All right, so to give you a little bit of a break here, we'll end here, but what I want to do first, I'm going to grab control back real quick, and I just want to bring up the email addresses that I promised earlier. There we go. And for anyone watching on recording. All right, so there you go. So there's my email address as well as Kiara's. So if you did have a question today that either did not get answered or that didn't get answered to the fullest extent that you would like, feel free to reach out to one of us and we will try to get back to you. If there's anything else, as I mentioned later in my later slides, from a future presentation perspective, about a month from now, Friday, August the 19th will be our next session. And then we have the one on September 16th. Any future suggestions, also send them off to me. Otherwise, Kiara, thanks today. Everyone, thank you for attending. If you're watching on recording, thanks for watching this recording. And hopefully we will see everyone again on August the 19th. And as you could tell from today's session, the more the merrier that show up live, because we get lots of good questions. So if you're watching on recording, make a note. The next one's going to be on Friday, August the 19th. Show up live and you can ask your own questions. So thanks again for attending today, and we will see everyone again in about a month. Goodbye.
Thank you, everyone.